Imagine standing on the shore, not of a gentle beach with lapping waves, but on the edge of the world itself. Before you stretches an infinite expanse of churning, furious water, a realm where the very concept of control is a laughable fantasy. The sky isn't blue, it's a bruised palette of slate gray, charcoal, and deep, ominous purple, with clouds so low and heavy they seem to press down on the surface of the ocean, threatening to merge with it. This is not a place for humans. This is the domain of raw, untamed power, a stormy sea with dark clouds and powerful waves. But what if I told you that this terrifying spectacle, this masterpiece of chaos, holds within it secrets that mirror the very universe we live in? That the patterns in its rage are the same patterns that govern galaxies, the growth of trees, and even the beat of your own heart. Today, we are not just looking at a storm. We are decoding a language, a primordial code written in water and wind. We are going on a journey into the heart of the storm to understand the physics that forge these monstrous waves, the meteorology that paints these apocalyptic skies, and the profound, often overlooked, philosophical truths this scene imprints on the human soul. This is more than a weather event. It's a living, breathing entity, and by the end of this exploration, you will never see a crashing wave or a dark cloud the same way again. So, let's begin at the very beginning, at the quiet genesis of this fury, far, far away from the shore. The story of a stormy sea never starts in the sea. It begins with a whisper in the atmosphere, a subtle inequality. Somewhere over a vast, sun-drenched ocean, the sun heats the air, causing it to rise, creating a void. Cooler air rushes in to fill that void. This is the birth of wind, the first breath of the eventual storm. But for a true tempest to form, we need energy, vast quantities of it, and we need a catalyst. That catalyst is often a low-pressure system, a giant atmospheric whirlpool. As warm, moist air rises into this developing low, it cools, and the moisture condenses into countless billions of water droplets, forming those massive, towering cumulonimbus clouds, the dark clouds of our scene. This condensation releases latent heat, which is like throwing high-octane fuel on a fire. It powers the system further, causing more air to rise, more wind to rush in, and the engine of the storm begins to spin faster and faster. Now, transfer this maelstrom in the sky onto the canvas of the ocean. The wind, now howling at gale or hurricane force, grips the surface of the sea. At first, it just ruffles it, creating ripples. But as the wind persists, blowing over an increasing distance, what scientists call fetch, those ripples become chops. The chops become swells, and the swells become the powerful, terrifying waves we associate with a storm. But a wave is not just a moving hill of water. That's the most common misconception. The water itself isn't traveling horizontally across the ocean in that great, sweeping motion. It's mostly energy traveling through the water. Picture a field of wheat in the wind. A wave moves through it, the stalks bending and rising, but no single stalk travels across the field. It's an orbital motion, a circular dance, forced upon the water particles by the wind's energy. In deep water, this motion is almost perfectly circular, diminishing with depth. But as this wave train, this army of energy approaches the shore, everything changes. The seafloor shallows, and the circular motion of the water particles at the bottom of the wave gets compressed, interrupted. The wave's energy, still barreling forward, has nowhere to go but up. The wave slows, its back catches up to its front, and it steepens and steepens until that elegant transfer of energy becomes unstable. The orbital motion breaks. The top of the wave, devoid of support, comes crashing down in a cascade of white fury. That crash is the sound of energy being dissipated, of the ocean finally releasing the immense gift or curse bestowed upon it by the storm winds hundreds of miles away. But those dark clouds overhead are not just a backdrop, they are active, malevolent participants. Their darkness is a function of their sheer size and density. A cumulonimbus cloud can tower over 12 miles high from near the sea surface to the stratosphere. At its base, it's a rolling, boiling mass of water droplets. Higher up, where temperatures plunge far below freezing, the droplets become a slurry of supercooled water and ice crystals. This vertical architecture is a factory for extreme weather. Within those clouds, powerful updrafts and downdrafts coexist, creating violent electrical charge separations, positive charges collecting at the top, negative charges pooling at the lower parts. The result is the storm's terrifying soundtrack, lightning. A bolt of lightning can heat the air around it to 30,000 degrees Celsius, 5 times hotter than the surface of the sun. This instantaneous, explosive heating causes the air to expand at supersonic speeds, creating a shock wave we hear as thunder. And then there is the rain. It's not a gentle shower, it's a torrential, blinding deluge, often driven horizontally by the wind, stinging any surface it hits. This rain further weighs down the air, and when combined with the complex dynamics of the storm, can lead to even more ferocious wind patterns, like microburst columns of air screaming downward at over 100 miles per hour, which then hit the sea surface and spread out, churning the waves into an even more chaotic, confused state. This is where the sea becomes a cross-sea or square waves, where wave systems from different directions collide, creating a checkerboard pattern on the surface that is mesmerizing from afar, but lethally unpredictable for any vessel caught within it. The storm, therefore, is a conversation, a violent feedback loop between ocean and atmosphere. The wind makes the waves, but the waves, in turn, influence the wind, breaking up its flow and transferring moisture and heat back into the air. The clouds birth the rain and wind, and the sea responds with its own chaotic artistry. It is a single, interconnected system, a beast with 2 bodies, one of air, one of water. To witness this from land is humbling. To be caught in it at sea is a defining human experience, often the border between life and death. For centuries, sailors have spoken of rogue waves or freak waves with a mixture of myth and dread. These were considered sailors' tales, exaggerations of frightened men. But science has now confirmed they are terrifyingly real. In the chaotic soup of a stormy sea, wave energy can, through a nonlinear process called modulational instability, suddenly and temporarily concentrate into a single, monstrous wave that towers over its neighbors, sometimes reaching heights of 80, 100, even 120 feet. It is a wall of water, a moving mountain. The Dropner wave in the North Sea in 1995, recorded by instruments on an oil platform, was the first definitive proof a single wave, measured at 85 feet in a sea where the average wave height was around 40 feet. These waves are not just bigger, they are shaped differently, with a steeper, more vertical front like a liquid cliff. The force of such a wave is incomprehensible. It can snap a massive cargo ship in two, or crush the superstructure of an oil tanker. Modern ship design and forecasting have improved, but the stormy sea retains its capacity for surprise, reminding us that our models are just sketches of a reality far more complex and powerful. This inherent unpredictability is what feeds the primal fear. It is the fear of the unknown, of forces that operate on a scale that reduces human endeavor to insignificance. A stormy sea is the ultimate representation of nature's indifference. It does not rage at you, it simply rages, and you are in its path. This indifference is perhaps more frightening than any malevolent intent. It strips away illusion, confronts us with our fragility, and in doing so, forces a profound introspection. What are we in the face of this? What is our civilization, our technology, against the billion-year-old rhythms of a planet expressing its sheer physicality? Yet within this chaos, there is a deep, resonant order. Scientists studying fluid dynamics and chaos theory see in the stormy sea a perfect example of a turbulent system. The waves, the swirling clouds, the patterns of foam and spray, they appear random, but they are governed by the precise, if infinitely complex, mathematics of the Navier-Stokes equation. They exhibit fractal patterns, where similar shapes repeat at different scales. The curl of a breaking wave mimics the larger swirl of the cloud formations, which in turn mirrors the spiral of the low-pressure system seen from space. This is where our metaphor expands. The stormy sea is not an anomaly. It is a concentrated expression of how the universe often works. The same principles that create swirling galaxies of stars govern the swirling vortices in your coffee when you stir it. The feedback loops between ocean and atmosphere are echoes of the feedback loops in ecosystems, in economies, in the neural networks of our own brains. The storm is a teacher of interconnectedness. It shows us that you cannot disturb one part of a system, the atmosphere, by adding heat. For instance, without expecting a complex, often violent, response in another part, the ocean rising, waves intensifying, storms becoming more potent. In our age of climate change, the image of a stormy sea has transcended the poetic and become a stark, scientific icon. It is a visual shorthand for the energized, unbalanced planet we are creating. The increased thermal energy in the oceans and atmosphere is quite literally adding fuel to the storm engine. The dark clouds and powerful waves are becoming more frequent, more intense, more loaded with precipitation. So when we look at this scene now, we are not just looking at nature's fury, we are looking in a mirror, seeing the reflection of our own collective actions amplified and hurled back at us in the form of wind and water. It is a canvas of both natural majesty and human consequence, a painting that is still being made with strokes we influence every single day. Let's dive deeper, beneath the surface of those powerful waves, into a world transformed by the storm. The raging chaos above is only the visible cap of a phenomenon that reaches hundreds of meters down. The sunlit, clear blue ocean we associate with documentaries vanishes. In its place is a dim, turbid, and violently agitated realm. The first and most critical change is light, or the catastrophic lack of it. Those dark clouds act as a thick, oppressive blanket, blocking up to 99% of sunlight. What little light penetrates is then scattered and absorbed by the churning, sediment-filled water. The world below becomes a monochrome landscape of greens and grays, a twilight zone pushed to its extreme. For marine life, this is a sudden, dramatic shift. The entire photosynthetic engine of the ocean, the phytoplankton, the kelp forests, the coral reefs grinds toward a halt. It's as if the entire region has been plunged into an unexpected, prolonged night. But this darkness is not silent or still. It is filled with the physical violence of the wave's energy. While the orbital motion of deep water waves may not move water horizontally, it does move it vertically with immense force. This creates powerful subsurface currents and shear forces that can rip at the seabed. In shallower coastal areas, the effect is apocalyptic. The wave's energy is directly transferred to the seafloor, scouring it, kicking up decades or even centuries of accumulated sediment. Sand, silt, mud, and tiny organisms are thrown into suspension, creating a dense, suffocating cloud. This is known as resuspension. For bottom-dwelling creatures, clams, worms, crabs, burrowing fish, this is a disaster. Their homes are buried or eroded away in an instant. Gills become clogged with abrasive particles. The fine, silty mud can smother entire ecosystems. A single major storm can reshape a coastline, obliterating sandbars, creating new channels, and redistributing millions of tons of material in a few hours. But this destruction is also a form of renewal. That sediment, rich in organic matter and nutrients long locked away on the bottom, is now mixed into the water column. It's a brutal, wholesale fertilization of the upper ocean. After the storm passes and the seas calm, this nutrient soup, combined with returning sunlight, will trigger massive plankton blooms, fueling the entire food web from the bottom up. The storm in its mindless violence is a reset button for marine fertility. It breaks up stagnation, redistributes resources, and creates new opportunities. It is the ocean's way of tilling its own soil, a painful but necessary process for long-term health. The pressure changes underwater during a storm are equally dramatic. The low atmospheric pressure of the storm system itself allows the sea surface to rise slightly, a phenomenon called the inverse barometer effect. But more significantly, the towering waves create rapid, colossal fluctuations in hydrostatic pressure for anything caught beneath them. As a wave peak passes overhead, pressure increases. As a trough passes, it decreases. For creatures with swim bladders, like most bony fish, this is a debilitating ordeal. A swim bladder is an internal gas-filled organ that helps fish control their buoyancy. Rapid pressure changes can cause this bladder to expand or contract violently, causing intense internal damage, a condition akin to the bends in human divers. Fish can become disoriented, unable to maintain their depth, and can even be forced to the surface or down to crushing depths. Many fish instinctively dive deeper before a storm, seeking the more stable pressures of the abyss, even if it means venturing into colder, darker, less familiar territory. Others, like sharks and rays which lack swim bladders, are less affected and may even use the turbulent conditions to their advantage, hunting disoriented prey. The soundscape underwater is also utterly transformed. The peaceful clicks, pops, and songs of the marine world are drowned out by a relentless, deafening roar. The crash of every breaking wave sends powerful shock waves through the water. The howling wind creates a constant low-frequency rumble. Rainfall on the surface, even, creates a unique, high-frequency pitter-patter that can travel down and mask other sounds. For animals that rely on sound for communication, navigation, and hunting like dolphins, whales, and many fish, this is like trying to have a conversation in the middle of a roaring heavy metal concert. Their world goes dark and deaf. Cetaceans may change their vocalizations, increase their volume, or simply fall silent and rely on other senses until the storm abates. Some evidence suggests large whales might even use the cover of storm noise to communicate over longer distances with low-frequency calls that can normally be heard by predators or competitors, a form of acoustic camouflage. Now consider the coastline, the fragile interface where this oceanic fury meets the solidity of land. This is the battlefront, where the true sculpting power of the storm is on full display. Powerful waves are the ultimate geological tool. They are not just water, they are liquid sandpaper, battering rams, and bulldozers all in one. The force of a large wave hitting a cliff can exceed several tons per square foot. This hydraulic action forces air into cracks in the rock, compressing it. When the water retreats, the air expands explosively, widening the cracks over time. Simultaneously, the water itself, laden with sand, pebbles, and rocks, acts as abrasive ammunition, grinding away at the rock face in, a process called corrosion. The cliff is undercut, eventually leading to a catastrophic collapse. This is how sea arches, stacks, and caves are born, through sustained, storm-driven demolition. On sandy beaches, the process is one of massive transport. Waves crashing at an angle create longshore currents that can move thousands of cubic yards of sand per day, stripping it from one beach and depositing it on another, or carrying it out to sea to form offshore bars. The storm surge, the abnormal rise in sea level due to the storm's low pressure and winds piling water up against the coast, is often the most destructive element. It allows the powerful waves to reach far inland, attacking areas that are normally safe from the sea's reach. It is the surge that causes the catastrophic flooding, breaching dunes and seawalls, and scouring the land down to its bedrock. A single storm can erase decades of coastal development in a few tidal cycles. Yet, this too is part of a dynamic equilibrium. Coastal systems are not static, they are meant to move, shift, and absorb this energy. Barrier islands, dunes, and wetlands are nature's shock absorbers. They are sacrificed in the storm to dissipate its energy, protecting the mainland behind them. When we build rigid structure seawalls, concrete revetments in place of these flexible systems, we often simply redirect the storm's energy to our neighbor's property or to another, more vulnerable part of the coast, ultimately increasing the total damage. The storm teaches us humility in coastal engineering. It shows that we must work with the natural processes of erosion and deposition, not against them, because the sea, given enough time and power, will always win any outright war of attrition. For humanity, the relationship with the stormy sea has evolved from pure terror to a complex mix of fear, understanding, and even a seeker's reverence. In ancient times, storm gods like Poseidon, Neptune, or the Norse Aegir were among the most feared and respected deities, reflecting humanity's absolute vulnerability to the sea's whims. Sailors developed an intricate, experiential lore reading the color of the sky, the behavior of birds, the shape of the clouds. Mackerel scales and maris tails make tall ships carry low sails. Their survival depended on this hard-won knowledge. The invention of the barometer in the 17th century was a revolution, allowing people to see the drop in pressure that preceded a storm, providing a crucial, objective warning. Today, our understanding is space age. We have a fleet of satellites monitoring sea surface temperature, wave height, cloud formation, and wind speed across every square mile of the global ocean. Supercomputers run atmospheric models that can predict a storm's path and intensity days in advance. Buoys and underwater sensors provide real-time data from the heart of the fury. This scientific mastery has saved countless lives, allowing for orderly evacuations and preparations. But it has not eliminated the risk, nor the awe. Instead, it has channeled it. We now have storm chasers of the sea, scientists who deliberately sail into hurricanes on specially fortified vessels like the Noailles ship Ronald H. Brown to release instrument packages called dropsondes directly into the eye wall, gathering data that improves future forecasts. We have filmmakers and photographers who risk their lives to capture the sublime beauty and terror of these events, bringing the experience to those of us safe on land. And we have a new cultural appreciation. The stormy sea is no longer just a hazard, it is a subject of art, a metaphor in literature and film for internal turmoil, a challenge for extreme athletes like big wave surfers who towed in by jet skis now ride waves the size of office buildings at places like Nazaré, Portugal. This pursuit is a modern, almost philosophical engagement with the storm. It is not about conquering the wave that is impossible. It is about a momentary, precarious harmony with it, about reading its energy perfectly enough to dance with the chaos for a fleeting, glorious moment before it inevitably crashes down. This human desire to not just flee, but to witness, to understand, and even to engage with the stormy sea on its own terms speaks to a deep, paradoxical draw. We are simultaneously the small, frail creature seeking shelter and the conscious mind striving to comprehend the immense. The storm makes us both. To truly grasp the scale of a stormy sea, we must pull our perspective back not down into the depths, but up, far up, into the void of space. From this godlike vantage point, the storm reveals itself not as local chaos, but as a beautifully organized, planetary scale structure. What appears from a ship's deck as an endless, heaving chaos of gray and white is, from orbit, a majestic, swirling pinwheel. A mature extratropical cyclone or a hurricane is one of the most strikingly geometric features on Earth. Its spiral arms, composed of those dark clouds and powerful waves, can span 1,000 miles, covering entire seas and coastlines within its influence. The center, the eye, is a place of eerie calm, a cylindrical hole of clear sky sinking down from the stratosphere, surrounded by a vertical wall of the storm's most intense clouds, the eye wall. This structure is a heat engine, a giant machine for redistributing energy from the warm tropics to the cooler poles. It is a critical part of Earth's thermostat. Seeing it from space strips away the visceral terror and replaces it with a chilling awe for its systemic perfection. It is alive, it breathes, it consumes warm water vapor, and exhales wind and rain. It has a lifespan, a path, and a behavior that scientists can track and analyze like a biologist studying a great migrating beast. This spatial perspective is crucial because it connects the local event to the global climate system. That storm battering a coastline didn't appear out of nothing. It was born from a kink in the jet stream, a pocket of warm water thousands of miles away, an interaction between high and low pressure systems over continents. The satellite view shows us the threads that weave the tapestry of our weather. It shows us how a storm brewing off the coast of Africa can intensify over the Atlantic, drawing energy from ocean temperatures warmed by a cyclical pattern like the Atlantic multidecadal oscillation, perhaps given an extra boost by the broader background warming of climate change before turning northwest to impact the Caribbean and the United States. Every storm is a local expression of a global conversation between ocean, atmosphere, and land. Now, let's talk about power raw, quantitative power. We throw around words like powerful waves, but what does that mean in joules and watts and atomic equivalents? The numbers are staggering, bordering on the incomprehensible. A single fully developed hurricane can release heat energy equivalent to a 10-megaton nuclear bomb exploding every 20 minutes. Its total kinetic energy, the energy of its winds, might be half that of the world's entire electrical generating capacity. Now, focus that down to the waves. The power of a wave is proportional to the square of its height and to its period, the time between wave crests. A modest 10-foot high wave with a 10-second period generates about 50 kilowatts of power per meter of wave crest. That's enough to power about 10 homes. But we're not talking about modest waves in a storm. We're talking about waves over 50 feet high with longer periods. A 50-foot wave with a 14-second period can generate over 1.5 megawatts per meter. That's the output of a large wind turbine concentrated in a single moving line of water. Now, imagine a storm for hundreds of miles wide with thousands of these waves marching in train. The total wave power being generated and dissipated is on the order of terawatts, trillions of watts. This is the same order of magnitude as the total rate at which humans consume all forms of energy globally. The stormy sea, in its rage, is producing and expending energy at a rate comparable to the entire industrial and technological output of human civilization. This is the scale we are dealing with. This is why a wave can snap a steel hull, demolish a concrete pier, or move multi-ton boulders. It is not just water moving. It is a colossal transfer of atmospheric energy into mechanical, hydraulic energy. When we talk about harnessing wave power for renewable energy, we are attempting to siphon off the faintest whisper of this monumental force to tap into the planet's own weather engine. And even that whisper, captured reliably, could power a nation. This quantification doesn't diminish the storm's majesty, it elevates it. It moves it from the realm of poetic metaphor into the realm of epic geophysics. We are witnessing one of the most powerful natural phenomena on the surface of our planet. With this cosmic perspective and quantified power in mind, let's examine the most critical modern context for the stormy sea, climate change. The relationship is direct and alarming. The storm engine runs on warm ocean water and atmospheric instability. Climate change is turning up the thermostat and adding moisture to the air. The physics is straightforward. Warmer sea surface temperatures provide more latent heat to fuel stores. For every 1 degree Celsius increase in ocean temperature, the atmosphere can hold about 7% more water vapor. This is like giving the storm more ammunition. The results are visible in the data, not as a simple increase in the number of storms everywhere, but in a worrying shift in their character. Storms are becoming more intense, more rapidly. The probability of a tropical storm escalating into a major hurricane, Category 3 or above, has increased. The storms are also getting wetter. Think of Hurricane Harvey in 2017, which stalled over Texas and dumped over 60 inches of rain in some places. Clear example of a storm carrying vastly more moisture, leading to catastrophic freshwater flooding far from the coast. Furthermore, there is evidence that storms are intensifying more quickly, a phenomenon known as rapid intensification, where wind speeds increase by 35 miles per hour or more in 24 hours. This poses a massive challenge for forecasters and emergency managers, as communities may have less time to prepare for a storm that suddenly explodes in strength just before landfall. Sea level rise, another direct consequence of climate change, acts as a force multiplier for storm surge. A storm surge that would have reached 10 feet above a normal high tide a century ago might now reach 12 or 13 feet because the baseline sea level is higher. This pushes the destructive power of the waves farther inland, affecting more people and infrastructure. The stormy sea of the 21st century is therefore a different beast than that of the past. It is supercharged. The dark clouds are darker, holding more rain. The powerful waves are riding on a higher sea, leading to more erosion and flooding. The icon of natural fury is now also an icon of human-induced planetary change. When we see satellite imagery of a perfect, terrifying spiral over an ocean that is several degrees warmer than average, we are looking at the past, present, and a portent of a more volatile future. This is no longer just a natural spectacle, it is a climatic feedback, a symptom of a feverish planet. This new reality forces us to reconsider not just our coastal engineering, but our very philosophy of coexistence with the ocean. The traditional model has been one of defense and resistance, build higher walls, stronger levees, bigger pumps. But the stormy sea, especially in its amplified form, teaches the futility of a purely defensive war. The Dutch, who have lived below sea level for centuries, are pioneering a concept called living with water. Instead of seeing water as an enemy to be kept out at all costs, they are designing landscapes that can safely accommodate flooding. This includes creating strategic floodplains, building floating neighborhoods, and designing parks that can temporarily become retention ponds during a storm. It's an architecture of resilience rather than rigid resistance. Similarly, coastal restoration projects that rebuild barrier islands, dunes, and salt marshes are increasingly seen not as environmental luxuries, but as critical infrastructure. A healthy wetland can absorb a massive amount of a storm surge's energy and reduce wave height before it reaches a city. These are soft defenses that work with the natural dynamics of the stormy sea, bending instead of breaking. On a societal level, it requires a painful but necessary reckoning with zoning and insurance. Continually rebuilding in the most vulnerable, high-risk areas after every storm is a cycle of economic and human tragedy. Managed retreat, the deliberate, planned movement of communities away from high-risk shores, is becoming a necessary, if emotionally difficult, conversation. The stormy sea, through its increasing power, is redrawing the map. It is forcing a profound existential choice. Will we continue to fight a losing battle against a force of nature we have energized, or will we adapt, retreat, and learn to respect the new boundaries of its fury? This is the great, uncomfortable question posed by every satellite image of a massive cyclone, by every news report of a flooded coastal city, by every piece of driftwood thrown far inland, by waves that should never have reached that far. The answer will define the future of millions of people and the shape of our coastlines for centuries to come. The storm is no longer just a natural event, it is a messenger, and its message is becoming impossible to ignore. Let's shift our lens from the global and the future to the intimate, the immediate, and the sensory. What is it actually like to be in a stormy sea? Not in a massive ship, but in a smaller vessel, or worse, in the water itself. This is the human experience at its most raw and elemental. First, the sound. It is a cacophony that consumes everything. The wind is not a whistle, it is a scream, a roar that varies from a deep, booming bass as it gusts over the waves to a high, tearing shriek as it funnels through rigging or past any structure. This sound is constant, oppressive, and maddening over time. Underneath and through it is the sound of the water, the hiss of spray being ripped from wave tops, the explosive crash of a breaking wave, the deep, guttural humph as a large swell lifts the hull, and the shuddering, grinding vibration as the vessel slams down into the trough. There is no silence, only a relentless, exhausting orchestra of violence. Then the smell. The air is saturated with salty, sharp, tangy aerosol that coats your lips, your face, your clothes. It's mixed with the ozone scent of electrical activity, a clean, metallic smell that hints at the lightning flashing in the clouds. If you're near land, there might be the dank, organic smell of churned-up seabed or torn kelp. It is the smell of the ocean being violently rearranged. Now, the sight. This is not a static view. Your horizon is a tilting, heaving, dizzying madness. One moment, you are climbing a liquid mountain, the wave towering above you, its crest a chaotic, frothing menace against the dark cloud base. The sky is reduced to a small patch of bruised color. The next moment, you are plunging into a deep valley, surrounded by walls of water that block out the world, the sky just a narrow slit above. The water itself is not blue-green. It is a forbidding, leaden gray, almost black in the troughs. The wave faces are a darker slate, streaked with white veins of foam. When a wave breaks, it explodes into a chaotic, opaque white, a temporary volcano of aerated water. Spray fills the air like a constant, stinging mist, reducing visibility to a few hundred yards, sometimes to just the length of the ship. The light is a dim, diffuse gray, with no shadows, no sun, no sense of time. It could be dawn, noon, or dusk. In the heart of the storm, time loses its meaning. For the body, it is a test of endurance that goes far beyond mere seasickness. It is a constant, brutal battle for balance and control. Every muscle is clenched, not from conscious effort, but from the involuntary need to brace against the violent, unpredictable motion. You are thrown against bulkheads. You grip handrails until your knuckles are white. You walk in a desperate, lurching crouch. The motion is not a simple rocking. It is a compound 6-degree of freedom chaos, heave, up, down, sway, side to side, surge, forward, back, combined with roll, pitch, and yaw. Your inner ear, the body's gyroscope, is in a state of constant, confused alarm. This leads to a profound, debilitating nausea, for many not just an upset stomach, but a complete systemic revolt, where the brain, receiving conflicting signals from the eyes and the inner ear, concludes it is being poisoned and triggers intense vomiting and lethargy. Even for those with strong sea legs, the fatigue is bone deep. The body cannot ever truly relax. Even sleep, if it comes, is a tense, fragmented thing, punctuated by the violent lurches of the vessel. The cold is another relentless enemy. The wind strips heat from the body with terrifying efficiency, wind chill. The constant spray soaks through even the best gear, leading to a damp, penetrating cold that seeps into the core. In northern storms, hypothermia is a constant, creeping threat. In this environment, simple tasks, making food, using the head, checking a chart, become monumental, dangerous challenges. A lapse in concentration, a moment of lost footing, can mean being thrown across a cabin, or, worse, overboard. And overboard in such conditions is almost always a death sentence. The water is a maelstrom. Even with a life jacket, a person is at the mercy of the waves, being dragged under by the suction of breaking crests, battered by debris, and quickly overcome by exhaustion and cold. The ship, even if it sees you, may be utterly incapable of turning around or launching an effective rescue in such seas. This is the stark, unromantic reality. To be in a stormy sea is to be reduced to a state of pure animal survival, clinging to a tiny island of order in an infinite expanse of chaos. Yet, within this extreme experience, many who have endured it speak of a paradoxical, transcendental clarity. When all the abstractions and complexities of modern life are stripped away, when your world shrinks to the next wave, the next grip, the next breath, a strange focus emerges. The mind, overwhelmed by immediate physical survival, ceases its normal chatter. There is no past, no future, only the visceral, pounding present. In this state, a deep, primal connection to the elements can surface. You are no longer an observer of nature. You are a participant, a piece of organic matter caught in a geophysical process as old as the planet. This can generate a humbling sense of scale, a realization of your own insignificance that is oddly liberating. All petty concerns, all social anxieties, all personal dramas are washed away by the sheer, overwhelming magnitude of the storm. You are reminded, in the most direct way possible, that you are alive. Every moment of survival is a victory. The warmth of a dry bunk after a watch on deck, a sip of hot liquid, the simple, solid feel of a handrail, these become profound, exquisite pleasures. The storm becomes a brutal but effective reset for the human spirit, burning away the non-essential. It forges bonds between crewmates that are deeper than most friendships, forged in shared adrenaline, mutual dependence, and survived terror. This is why survivors' tales, from the ancient voyages of Odysseus to modern-day sailing memoirs, hold such power. They are not just adventure stories, they are archetypal journeys in the abyss and back. Stories of being broken down to one's core and finding out what remains. Often, what remains is a newfound, quiet respect for the sea, for the storm, for the vessel, and for the fragile, stubborn flame of human life that can, against all odds, persist through such an ordeal. It is an experience that marks a person forever, leaving them with a look in their eyes that those who have not been through it can never fully understand. They have seen the world at its most raw, and have seen themselves reflected in it. This sensory and psychological journey leads us to a final, crucial point about the stormy sea, its indispensable role in art, literature, and the human imagination. The storm has never been just a weather event, it is a universal metaphor. In Homer's The Odyssey, the stormy sea is the agent of the gods, an obstacle on the hero's journey home, representing the capricious forces of fate that test human cunning and endurance. In Shakespeare's The Tempest, the storm is both a literal event and a symbol of political upheaval and magical power, used to shipwreck characters on an island where their true natures are revealed. For the romantic painters like J.M.W. Turner, the stormy sea was the ultimate subject for the sublime, that aesthetic category where beauty is mixed with terror, where nature's power overwhelms the human scale, evoking awe and a pleasurable fear. Turner's paintings, like Snowstorm, Steamboat Off a Harbor's Mouth, are not photorealistic. They are impressions of chaos, vortices of paint that convey the feeling of being in the storm more than its literal appearance. In music, from Vivaldi's Storm Concerto in the Four Seasons to the dramatic swells in Wagner's operas or modern film scores, composers have used orchestral fury to mimic the rising wind, crashing waves, and thunderous skies. The storm is a narrative device. It creates conflict, forces change, and isolates characters, stripping them down to their essentials. Film, The Stormy Sea, is a character in itself, the antagonist in The Perfect Storm, the transformative trial in life of Pi, the majestic danger in documentaries like The Finest Hours. It represents internal turmoil, the unconscious mind, chaos, purification, and rebirth. We are drawn to these representations because they allow us to safely experience the terror and the awe. We can sit in a comfortable theater or gallery and feel a shiver of fear, a swell of emotion, without any of the actual risk. The artist acts as a mediator, translating the immense, non-human power of the storm into a form that our human senses and